little bit of an intro to NATS. I'll write some code, and then we can, kind of open this up and chat more about what we've been working on, what we've been thinking about, everything like that. So my name's Jeremy. I'm an engineer at Synadia. We maintain the NATS open source. We maintain the NATS open source project, and we also work on a service called NGS, which is kind of like big NATS, more global utility for hosted NATS. We also, support larger companies who are using NATS out in the wild with enterprise. Just so you know, that's our offering. But we actually employ a lot of the folks who maintain NATS as core maintainers. A little bit about me. I'm actually a returning Gopher. I worked in the Go community back in 2013, 2014, some early days, and worked on some pretty popular open source projects. Took a little bit of a detour and helped build up a company and worked on our product management department. And just recently returned to wanting to jump in and be more of a full-time engineer. And I found this technology called NATS that was really, really cool. And I got to talk with Derek and really get to understand some of the bigger vision behind this. So I'm going to start out by talking a little bit more about that bigger vision and why we think it's really important to start considering technologies like these when we're starting to work on projects, greenfield or even brownfield, that involve microservices. So at Synadia, we talk a lot about this idea of rethinking connectivity, mainly because every decade or two, there's a huge kind of leap in terms of what not just our expectations, but everybody's expectations that's interacting with technology like this. Expectations start to change, and you start running into situations like this, where everybody knows what this is. It's a fax machine. And the funny part about fax machines is that, like, they're actually really cool tech. I mean, it was kind of a modern miracle to say, like, over telephone lines, we're going to like have a facsimile of a document show up for somebody. But this is now old, crusty, outdated tech. And the reason why is that a lot of our expectations changed, right? Communication, that our assumptions around what communication could be around a fax machine and being able to kind of replicate documents had certain assumptions, right? That documents were the way to be able to start thinking about these things. And we needed to start using our telephone lines to be able to ship those documents. And so what we're noticing here, is we have telephones. I mean, these are telephones, but they're not just telephones, right? These are smart devices where we're able to communicate in much different ways. We're now sending text messages, and I guess we don't call them text messages anymore. We just call them messages. There's so many different ways that we communicate now, but we've noticed this giant leap in how our expectations have changed as consumers of these technologies. And one of the big leaps that we're starting to see, especially kind of in the distributed systems and cloud computing space, is that this whole like multi-cloud and edge computing is just driving a massive transformation. Like, we're noticing this with so many of our customers, is that the expectations for how close our services need to be to the person who wants that data, not just our compute, but like our data as well. How close the data and the compute needs to be to the person who wants it or is requesting it. Those expectations are starting to change rapidly, to where our vision for the cloud can't just be relegated to something living in a certain data center somewhere. But it's now starting to change to, hey, what does it look like for us to be in multiple data centers, to have redundancy there, or to have things deployed as close as we can to the thing that needs it. And we're also starting to see some really interesting use cases at the edge, where whether it's a oil tanker or oil rig, or having these things on satellites, like, our requirements are changing for how this stuff should interact. And we're seeing this as one of the biggest driving trends to how we might need to start rethinking some of our fundamental technologies for how our microservices communicate. And so some of the limitations for today's tech is, right now, primarily, I mean, with the exception of some like very specific services to do this, we're using DNS and host names and IP for our service discovery. And in a lot of ways, we're bumping up against some of those edges in terms of how we scale that. And it's a lot of work to like really get that right in terms of a multi-cloud, multi-geo, disaster recovery and failover support. Like, that stuff starts to get really hard, right? We also communicate primarily via HTTP for a lot of these things, which is generally pull-based. I ask a question, you give me an answer back. And then any of the semantics that we want to bake into that, like, having to call back or everything like that, we have to kind of build these little layers on top of HTTP. And it gets a little difficult to be able to, manage some of that. It's, again, more layers of complexity. We've also started to see a lot of companies change their assumptions about what security looks like, right? Instead of putting everything in your VPC and creating policies around that, now that everything needs to be more distributed across the globe, like literally physically distributed, that those perimeter-based security models simply don't scale. And so now we're starting to see a lot more development in terms of zero trust constructs coming to organizations, and people are asking, like, how can we implement that in in an easy way that's more manageable, that we don't want to pull our hair out doing. Our backends are for the most part pretty location dependent, and that's going to get harder. Especially with more policy around where data is stored and where it is allowed to be stored and how that relates to our consumer privacy. Having location-dependent backends makes that really difficult. It especially makes the jump from like one data center to multiple, where we're supporting these different policies around data. It makes that particularly difficult. And lastly, and I touched on this a little bit, but HTTP is still kind of this one-to-one. It's assuming that like one machine is talking to another machine, and that's really limiting. So we have to build new semantics on top of that usually if we want to be able to kind of mux or demux how information flows throughout our systems. So these are kind of the problems that NATS is really positioned to solve. Which are big problems, right? And so that's why we keep talking about rethinking connectivity, because it's not just a simple, like some of you guys who know NATS, like it's not just a simple message bus. It's actually trying to solve really big distributed systems problems. So for those of you who don't know what NATS is an open source, high performance messaging system and something we call a connective fabric. It aims to simplify the number of technologies you use for your services to communicate, and also empowers you to build systems that are globally available. They're multi-cloud, they're multi-geo, and it's really going to help you be highly adaptive to change and scale, whether that's change and scale geographically, whether that's change and scale in architecture. NATS is built to kind of be a lot more adaptive to business needs, as well as technological needs in terms of change. So I'm going to talk more about that, and those are kind of the key points that I want to clue into as we start writing some of this code and diving into some of the features and everything like that. Again, to solve some of these problems, NATS has this idea of location independent addressing, meaning, I connect to a NATS server. Sure, I might use DNS or IP or whatever, but that's the initial connection. From there on out, if I want to talk to anything else in the system, I simply use subjects to be able to talk about those things. I don't care where this particular server that's responding to me is. I don't care if it's on the other side of the world. I don't care if it's right next to me. NATS is going to be smart about how to route it. I don't really need to care about that as a client or as a service. NATS also supports this idea of end-to-end communications. Rather than thinking about connectivity as being like, well, this machine talks to that machine, we want to think about it more as, how can we think about this as how we communicate now? This kind of town square mentality. What does it look like for somebody to go out on Twitter and go put something out into the world and have people respond to it? Some people might have different interests that they want to see. Some people might want to do something with that information, and some people might just want to observe it and keep it in the back of their mind. This is kind of the more natural way that we consider communication now, instead of just, well, I'm just going to talk to you, and I'm just going to talk to you, and I'm going to get requests and responses and everything like that. That's right now how a lot of our microservices work. And sure, like we do try to layer more technologies on top of it. We're going to pull in a message bus, and we're going to pull in, Kafka for persistence and streaming, and we're going to event source over here. And so like, we're kind of getting the idea, but like, I don't think all these technologies need to be separate single point technologies. I think we really think at Synadia that these things can be combined and built on some really simple constructs that make a lot of this much simpler to implement and use and evolve over time. NATS is also push and pull based, meaning, I can obviously still use this kind of pull methodology where I'm asking a question and getting an answer back, or I'm saying, I want to pull certain messages that I'm interested in, or I could just simply have the server send them to me. I could be a lot more reactive in how I build my applications and my microservices. Importantly, too, NATS is also decentralized and it's secure by default. I mean, we built from the ground up this idea of decentralization and security, where you'll start seeing these zero trust constructs come into play, where you can actually have these clusters and superclusters be extended if you want without your permission. So, some of the trends you've seen, in crypto, where like anybody could stand up their own server and contribute, like there's models that can be done like that in NATS as well, which can help scale organizations. We have a really good multi-tenancy model that helps with larger organizations or with just separation of concerns, where you can really operate this as kind of a utility, either inside of your org or inside of a project, and have this one single deployment meet all of these different use cases. You don't have to tune it to a specific use case or anything like that. You just have this one single deployment. And that's really like the panacea there, right? You don't want to have these point solutions that you're deploying and then tuning for specific use cases. And it's like, you can't really use it like that with how we have it configured. No, we want to be able to deploy one kind of topology, and we want it to be able to meet all the different use cases and evolve with different needs. We also have this idea, and I think this is where it's going to interest a lot of you guys today, of this intelligent persistence, where we really found that NATS core, being able to kind of do pub sub and messaging, request reply, was not enough if we couldn't have a way to persist that data. And what we noticed is when we solve for end-to-end communications and we persist that data, you can actually really build a lot of really unique and interesting things with the idea of materializing these views of data. Whether you want it to be a key value store or an object store that you chunk up and pull across the world, and a new kind of modern CDN. There's a lot of really interesting use cases that you could use once you have that kind of combination of end-to-end communication and persistence. Lastly, and I keyed into this as well, global scale. So NATS was designed to be multi-tenant. We wanted to prove out the use case by creating NGS, which is like this global utility where we've solved this Coke and Pepsi problem, where Coke and Pepsi could both be on the same infrastructure, but all of their data is still secured and encrypted and completely isolated. But if they wanted to, if Coke and Pepsi wanted to do something, they can, define imports and exports of their different data streams and get access to those things. And that's really what we wanted to solve at a global scale. And in some ways, your NATS deployment, or not in some ways, in all those ways, your NATS deployment could do things like that as well. Okay, so I know I just did a big spiel about kind of the vision of NATS. More concretely, NATS is a simple client-server model. The server is a small, easy to deploy Go binary, which brings a lot of benefits. You could run this thing on we've run it on a Raspberry Pi 02, which is great. You could run these little servers everywhere. They also scale up really nice. So if you want to throw it on like a Amazon extra large instance, you absolutely can, and it will use the resources effectively. In terms of client libraries, we have 40 plus client libraries in various languages, which is nice because you don't have to just say, we have to use Go everywhere for this. We also have support for things like WebSockets. So with the right security model and bearer tokens and things like that, you can actually start consuming these NAT subjects straight from the front end. Actually, I've done that. If you guys want to see it, I built an interactive live whiteboard that we could play with at the end of this talk. It's really cool. It's like 100 lines of JavaScript, and it really kind of shows you wow, you can build some really powerful things using NATS. Okay, so let's talk about NATS core. So I'd separate the NATS messaging API into two different buckets, and we'll do a demo on NATS core, and then we'll kind of evolve that into NATS Jetstream, which is the second part of this messaging API, which deals with the persistence and the materialized views and everything like that. But one of the advantages I see to NATS as opposed to a technology like Kafka is Kafka kind of assumes you're going to be doing streaming of data. And NATS tries to kind of zoom out a little bit and realize well, the atomic unit here is really a message. We're going to be a messaging system, and we're going to connect all of these things together. And if you need persistence, you can enable that. but you might not need persistence everywhere. And I think this is really cool, and it's a really good use case for microservices because you can actually use NATS to replace your HTTP stack or your gRPC while also using it to replace something like Kafka, or even in a lot of cases use our key value store instead of something like Redis. And you're using all of the same, you get all of the same benefits from putting them all into this one single deployment of a messaging system. So NATS core includes constructs like request reply, publish and subscribe, fan in and fan out, that end-to-end communication. But we also get like free load balancing via this idea of queue groups, which is really neat. It's a really simple to use API. I'm actually just going to show you right now. Before I jump into writing some code, does anybody have any questions?
I do.
Yes.
Can you hear me? Okay. So in the previous slide, you showed like that we have the NAT server and the NAT clients, right?
Yep.
So to my understanding, would there be we can say like a single server, and then we would have several clients, all of them connected to the server?
Yes.
And then if I want to publish a message, for instance, I should talk to the client that's in my code, and this client will then talk to the server, and then the server will publish that to all the other clients. Is that how it works?
Yeah, exactly. So kind of NATS is acting as this intermediary to where I don't have to worry about what service I'm talking to, what their domain name is, or their IP address. I'm skipping that whole networking layer. I'm just going straight to NATS and saying, here's this message that I have, right? Find somebody who's interested in it. And that's a really powerful construct, especially for some of these distributed systems.
So the clients, they don't need to care about other clients in the network, right?
Exactly. Yep.
Okay.
And because we're combining these request reply semantics with these publish and subscribe semantics, like it gets really powerful, because sometimes you're like, I'm just going to publish an event and whoever wants it can have it. I don't really care. Or sometimes you're like, I have a question and nobody can answer that. NATS will be like, nobody can answer that. But if somebody can, NATS will actually route you. And this is really important. I'll talk about it in the topology section a little bit. But NATS will actually route you to the geographically closest client that can respond, which is super powerful. Because imagine for a second that you have a service deployed just here in the US, in Portland, let's say. And then you have a client over in Berlin. And you're actually starting to notice you're getting a lot of like traffic from Berlin asking these same questions. And maybe it would be faster if we just deployed something in Berlin. Well, if you had to do that, you'd have to make sure you changed all your load balancers and make sure all of your topology was working correctly for that. With NATS, because it's all a single system, you simply just deploy your service in a data center that's closer. That's all you need to do. And NATS will intelligently start routing to that responder, any of this. Okay, so I'm going to just remove the stuff that I have in here right now. And we're just going to start with a fresh Go project. So let's say NATS demo. And to install the NATS client, it's just github.com, natsio/nats.go. This is kind of convention for everything. Like if you wanted to install WebSockets, obviously you wouldn't do it in Go, but like you would, fire up npm and install nats.ws. So we'll go get that. And then let's open up our project, and I'll add a main Go file here. And we'll start using NATS. So like I said, you do need a NATS server here. We actually have a NATS demo server that is already deployed, which is fun to play around with. But I'm just going to run one locally here for you guys just to show you how it's run. NATS servers, one of the things that's really hard to describe, because I say it's simple and it's easy, and it really is, because like if you want to run something like Kafka, you're already like taking the JVM with you, and there's like so much tuning involved to like get this thing set up. And while there is configuration for NAT servers and there's a lot of flexibility in deployments, being able to just run this thing is just like super easy. There you go. NAT server's running. Okay, so if I want to start playing around with this, first I need to connect to my NAT server. So I'll say nats.connect, and I'll connect to the NATS default URL because I just spinned up a server at the default URL. And this thing returns a NATS connection and an error. And like any good gopher, I'll handle this error with panic. No, I won't do a panic. Let's do log fatal. The error. some reason it's unable to connect. And once we have this NATS connection, we can simply subscribe to, NATS connection.subscribe. Subscribe to a particular subject. In this case, I'm going to go hello world. So NATS uses, like I said, these location transparent subject-based addresses. And you can actually use not just, you can separate these things out by dots, and you can use wildcards in the middle here. So you can start like creating subject hierarchies that that can be pretty complex, but allow you to like really like mux and demux and say, hey, I'm this service and I really only care about this particular thing, right? So I'm going to subscribe to this subject with a wildcard, or I'm going to just subscribe to this subject outright. I could also do, I can subscribe to like the rest of the string by doing that, or we call this wiretap mode, where you just be like, give me all of the messages, which can be really useful for things like monitoring and observability and things like that. So in this case, we're just gonna do a hello world subject. And like I said, the API is really simple. So you have a little message handler here, and you could treat this like you would any other web framework, which is really cool. Like this is a neat replacement for NetHTTP, because you get a lot of really cool things out of the box. So I'm just going to log.println. We'll just say message.subject. And that's going to give us the full subject, which is hello world in this case. And I'll just say received on. And then we'll make another print statement where we will print out the message.data. And in case you guys were wondering, this data is just a byte array. And so NATS doesn't have any preferences in terms of like what wire format you want to use, which is really cool. So you could be sending JSON or BSON, or I don't know, I like Captain Proto, so you could like send Captain Proto over the wire. But this is nice because like, especially if you have like a gRPC based setup, you could probably just like opt for like saying, well, we could just use NATS and Proto. We have a lot of our Proto definitions already, and you can run it that way as well. So and it's nice because NATS is supposed to be like more, we don't have a lot of opinions on this, because you want to be able to run this as a global utility, where it's like, well, maybe one team over here is like using JSON and another team over here is using Proto, and like that they can coexist. You don't have to tune the server to be able to, be forced to handle that. Lastly, if we want this to behave more like an HTTP request reply pattern, I could just leave this as is and just start being like consuming messages as a subscriber, but I could also choose to respond to this message. And I could send my own little array of bytes. Hey, dude. And that's it. I mean, that's all we really need to kind of have a hello world. Since NATS doesn't block like an HTTP listen, we have to block ourselves. So I'll just say runtime.goexit to block for me. And let's start playing around with this code. So I'll go run this. And it's connected to the NATS server. I don't have any print statements to confirm for me, but it has. And I can actually, we have a NATS CLI that's actually really robust. Let me see if I can make this a little bit easier to read. We have so many different commands around how to interact with Jetstream and with NATS, how to publish and subscribe. So it's actually really fun. I think it's really fun to build a bunch of POCs and everything just like purely with the NATS CLI. So I can say NATS, if I wanted to just publish a message and I didn't really care about a response for somebody, I could just say NATS pub hello.world. And I pass in just a blank string. I could say, hello if I wanted to. And I'm publishing that, and it looks like the receiver is getting it. Now it's sending a response, but because I don't care about the response, like NATS is just going to cut it short, right? Which is pretty great, because I only care about publishing this message, not necessarily the response. If I did care about the response, I can just simply say NATS request hello world, and then I can get that response back. Hey, dude. So, so that's kind of a basic hello world inside of NATS with NATS core. The last thing I want to show you is this idea of queue groups, because I mentioned this idea of like free load balancing, which is great. If I were to fire up multiple of these, like let's say I fire up another one of these guys, they would both get the messages, right? And that's natural, right? That's, one-to-many kind of communication. You kind of expect that from a subscribe pattern. But what if I wanted to just like have these be load balanced, and all kind of like to what I alluded to before, you could just spin up more instances and connect to the NAT server, and that's really all you need to do. No adjusting load balancers or anything like that. And so the way you do that is, instead of subscribe, I could just run a queue subscribe. Oops, if I knew how to spell it. There we go. You subscribe, and then as a second argument, I can specify a queue. This is just a name for the queue, and everybody who's on this queue will have messages distributed evenly between them. And I can actually have multiple queues as well, which is nice. So this is cool for like if you're wanting to write like a a job system. You can combine this with Jetstream to have kind of durable queues and things like that. Or if you just wanted to load balance things, like these were HTTP requests. So I'll run both of these again, and I'll start sending messages, and you see now it's flipping a coin. It's not going 1 2 1 2, but it's just evenly distributing the load. And again, I could just arbitrarily spin up more of these, spin them down. It makes for a really cool horizontal scaling story without any configuration, which is really nice. So that's a basic demo of NATS core. Again, you guys can grok the basics: pub, sub, request, reply, fan in, fan out, queue groups. But that's the basics of NATS, and then everything else we do here kind of builds on top of those like core semantics. Any questions before I move on?
Yeah, I have a quick question. How do you deal with partial delivery or failures during delivery? Let's say in a queue setup.
Yeah, it's a great question. And so, I think what you're mainly talking about is what we'd consider like qualities of service, which is a big conversation happening obviously in the streaming world. And so NATS messaging kind of works through a quality of service of at most once delivery, which means if there's disconnection problems or anything like that, if NATS can't find a subscriber on the other end, they're going to drop that message, right? So now we can move on to talking about Jetstream, which is kind of the natural, what you would expect there. We persist these messages, and we have certain quality of service guarantees that we have around those messages. But then we'll expand it to saying, well, if we're storing a lot of these messages, we can actually do some really cool things with them. So yeah, NATS kind of operates just like plain HTTP would, where it's like, if it can't find a connection, it's going to tell you it can't connect. And you'll have to implement the retry logic kind of yourself. NATS does do some buffering though, between the client and the server. So if there is kind of some shoddiness between the client and server connection, let's say you have a client that's like connecting over LTE, it will buffer messages. So when it connects to the server, it will send those back up. But that is different between like if a certain client is disconnected, between the server and itself. So, any other questions? Okay, cool. Let's move on to Jetstream.
I have one. Sorry.
Yeah.
Does the server keep some sort of track about the clients? Because you use like the message response. So how does it know which? Right, because you can have multiple clients, and then it will give a response to that specific client, right?
Right. So when you go to make a request, you actually the NATS client will automatically generate a special subject called an inbox subject, so that the NATS responder knows how to send a response back. But also, the NATS server does do a lot of really fancy things under the hood to keep track of clients and the interest graph and everything like that. The interest graph. Which makes for some really special interaction, especially when we start talking about Jetstream. So yeah, we do a little bit of magic under the hood to simulate request response, but it's all just messages at the end of the day. Let's talk about Jetstream, and then we'll jump back into the demo and layer some Jetstream on top of this. Jetstream's a huge subject. I'm not going to be able to cover all of it. There's so much to cover there, but it really is kind of what makes NATS super valuable, especially when you start thinking about this at a global scale. So Jetstream is a next-gen persistence layer that we've built on top of NATS core. It allows you to build these secure data streams with kind of these multiple consumer models and policies. So it not only does it kind of like replace the work of a durable queue, but it can replace like how something like Kafka operates. And you could also start building some materialized views on top of it to do things like key value and object stores and everything like that. From an operational perspective, you could also create these, digital twins. You could replicate data across different NATS servers very easily. You have a lot of control over that. You can also mux and demux data, meaning I can, say, hey, I want to create a new stream that's sourced from all these other streams, or I want to, create a stream that's only a subset of this stream with filtered by these subjects. And so you can have, streams kind of act like these assets with different owners and everything like that, which is great from a scalability perspective. I mentioned materialized views, but when you start thinking about, okay, we're saving these things and they're all just messages at the end of the day, we can actually create things like a key value store fairly easily, or we can create an object store like S3 very easily. And you can imagine as you're replicating these things in different geography, in different geos, it becomes a really powerful construct. And not only do you get the storage, but you also get kind of live updates and being able to watch KV stores. I remember back in the day just trying to figure out, how can we get config values to be, secure, but also we get live updates to them to update our clients. It's like, oh man, I wish I had this back in the day, kind of a live, live updating key value store with notifications that can be secure and encrypted at rest and in motion. So there's a lot of really cool, there's a lot of really cool things that you could do. And it's not just KV and object stores, but there's a whole bunch of different materialized views that you could build on top of this idea of a stream. And so you can also replicate state from a lot of external data stores. We're seeing our customers really engage with that, where they might be taking a Postgres database and starting to look into the events coming off of the wall and throwing that into a Jetstream for being able to either analyze or event source other models in their microservice architectures. Let's jump into a Jetstream demo. So I'll go back to my shell and we'll close these guys out. And we'll use the same example that we had, but we'll just layer Jetstream on top of it. So one of the things you have to consider, some people get tripped up on this, but there's a good reason behind it, is in these hybrid models, we're using NATS core and using Jetstream. You might not want to use Jetstream for everything. It might not be practical. I mean, there's a lot of cases where it might not be practical to just use Jetstream. You might not have enough disk or whatever. And so the NATS server is meant to be really stripped down, can run on anything, can really run without storage requirements or anything like that. So it means you have to run that server with the Jetstream flag in order to get Jetstream. And as we start thinking about clustering these NATS servers, sometimes you want in a cluster 1 or 2 Jetstream specific servers, and that all works out pretty well. So I'll run with Jetstream, and you see the big Jetstream banner. So now we're running this server with Jetstream enabled, and I could start using Jetstream. So the cool part is we actually have a lot of cool Jetstream management capabilities inside of the NATS CLI. So I can get a list of streams or a port on them, and we'll be using this throughout. I can also create a stream right here from the CLI, which is fun when playing around. I can also use things like Terraform. We have some Terraform provider for creating streams and consumers and stuff like that. But for now, I'm just going to actually just build this in code because there's actually a really great API for it out of the box that I can create a stream right here, and it basically no ops if it finds that there's a stream that already exists, which is great. So I can define a lot of my stream here in the code. So first, I'm going to create my Jetstream context, which I simply just say nats.jetstream, and we'll handle this guy here. Oops, not nats.jetstream, it's nats connection.jetstream. Then I can create my my stream. So I'll jetstream.add stream, and I gotta give it a stream config. And I'll just kind of fill this so you guys can see all the different configuration options you have for a stream. We have, I can talk about this a ton. We have a bunch of different policies for how you can run your retention inside of NATS. You can say throw away the oldest ones, when it reaches a certain limit, or give an error when a new one tries to come in, or I can say, have this behave like a work queue where it's as soon as another client's acknowledged that it's received the message, you can safely throw it away. There's a lot of different ways you can model, different streaming patterns here. But for now, a lot of these options you don't really need. You get rid of a lot of these, but as you can see, there's a lot of semantics that you can create just by configuring a stream. And all of those options obviously exist just on the stream. You don't have to tune the server to be able to do that. I'm just going to give this the name of my awesome stream. And then a stream can define multiple subjects to which it wants to persist. So I'm going to say hello world, since that's what we've been using here. And then add stream returns stream info and error. We don't need our stream info, but we should probably handle this error just in case. Good hygiene here. All right, so we can now, instead of telling NATS to subscribe to this thing, we want to tell, we want to say that we want to subscribe to this thing via Jetstream. So we can start using the Jetstream APIs to pull this down. Otherwise, everything else looks the same, which is great. The other awesome thing is that publishers don't actually have to change what they do, because publishers don't need to care whether they are using Jetstream. Only the people who are subscribing. And the reason for that, I'll go into it in a little bit, is kind of how the consumer semantics work. We actually have a really neat consumer model where a lot of the consumer info is stored on the server. So, you can do a lot of interesting things with that. But for now, I'm going to just say subscribe to this without specifying a durable consumer. And this is going to create actually what we call an ephemeral consumer, which is great for, especially for things like event sourcing. If you want to always just start at 0 and, accept things from the stream, then that's great. So I'm going to go ahead and run this. And I'm actually going to kill it now, because I think that stream just, got created. Let's actually inspect that stream. Okay. So I said NATS stream list, and you can see that there's my awesome stream. It has 0 messages in it. Let's actually start sending some messages. So I could just say NATS pub, hello world, foo, and let's just send 1,000 of them. Well, let's look at that stream again. It says it has 1,000 messages in it. NATS stream info for my awesome stream. It gives you some of the configuration and also says how much messages are in it. If there's any active consumers, you can have multiple consumers for a stream, which is great. And you can also see that there's only one subject on there for now. Okay, so let's actually start consuming this stream. If I fire this up, it's actually going to start consuming all the messages. And again, this is what we talked about. Like, hey, what if this thing's offline? How does it, know how to get its messages? Well, this is the solution for that, right? Is to persist these. And so it now got all of those messages. We can run NATS stream list. Oops, NATS stream info for my awesome stream. And you can see, yeah, it has 1,000 messages. Let's actually look at it says active consumers 1. Let's actually look at the consumers. So NATS consumer, what is it? Consumer info. NATS consumer info, my awesome stream. And look at this is a randomly generated token, because again, this is an ephemeral consumer, which means the server is going to get rid of it. There's a grace period if there's like little disconnections, but if I kill this server, essentially this consumer will go away. But I can inspect this and see that, it's delivered 1,000 messages, everything like that. So it gives you a delivery subject inbox and does a lot of kind of the heavy lifting for you. But what if we wanted to have a durable consumer? Because every time I would kill this and then, and then I would fire this back up, it's going to run through all the messages again, which you may want. But you might actually want, the server to kind of keep track of, well, how many messages has this thing consumed? Because maybe I'm just like inserting these things as rows in a database inside of a microservice. That's where you're going to want a durable consumer. So in there, you just pass in an option for your subscribe called nats.durable. Again, I can define this consumer via Terraform or in the NATS CLI if I wanted to, but I could also just do it straight from the code. I'm going to just say my consumer. I'll run this. And it's consumed those messages, which is great. If I run it again, it's not going to consume any more messages, and that's because the NATS knows a consumer. NATS has is keeping a cursor of how many messages that thing has consumed. And again, because this is all going through NATS, I can start publishing NATS pub, hello world, and hi, and publish those, and it just behaves like NATS always does. So there's no like special handling here, except that like Jetstream and streaming is layered on top, which is a really cool way to be able to kind of model your data, because you might just opt in for NATS core for a lot of your HTTP stuff, but for the stuff that's really important that you don't want to lose or you want to operate like a queue, you absolutely can do that. There's more. There's a ton more semantics around consumers and Jetstream and how you want to set them up. There's also, like I said, there's push versus pull. So like I'm getting Jetstream messages pushed to me, but if I wanted to pull in batches for some more efficiency, we have constructs around that as well. You could use channels if you wanted to consume messages, which is really great. Little feature in Go. And so there's a ton more semantics, but I also want to leave some more time to talk about topology and everything like that. I'll close with one more thing around the materialized views, just because it's so fun and whoops, pretty cool. Let me pull this up. Okay, let's talk about key value stores and object stores. So I'll just use a CLI for this. Again, we have an API for it in all of our client libraries. I can say NATS object. It's NATS object add to create a new object bucket, and I'll just call this my stuff. And I could say NATS object put main.go put it into my stuff. There we go. I've put a file onto a NATS object store, and this is all just built on top of Jetstream and NATS messages. We actually chunk all these objects up, so like we were testing with like a something crazy like a 17 terabyte file or something like that, and NATS will naturally chunk that up and use Jetstream to drive all of that. And the cool part is you get all the neat semantics around how you can move these streams around pretty easily between different clusters and replicate them and everything like that. Same thing with a key value store. NATS KV add my KV, and then NATS KV puts into my KV foo bar. And then I can say NATS KV get my KV foo. Or I can also say, tell NATS KV to like watch my KV, and it will give me, messages in real time. Again, we have an API for all of this, so if you wanted to kind of live update KVs, we have customers using this as a replacement for Redis in a lot of cases. It's not going to be as feature complete as Redis. We don't have like all the crazy sets and everything, the different data structures that Redis has. But if you're just using kind of a simple KV for stuff, we have customers that are using 20 million keys and continue to surprise us for how they're distributing this across the globe. So that's a high-level overview of kind of like how to use Jetstream.
Hey, Jeremy, I have a question about Jetstream as well. So
Yeah.
I see that you have like the first example when you sent 1,000 messages, then you ran your client again and it loaded all the 1,000 messages again and again. So if we have this Jetstream running for a week, for instance, then we have thousands and thousands of messages, and a client just joins. So then the client will be overflown with millions of messages, and also how does Jetstream keep track of that? Like, is it storing that information forever somewhere?
Yeah, so there's a couple different options for what you can do. Basically, there's an API for consumers, because the consumers actually kind of live on the server side. And so all really a consumer is something that has a name that knows that it's attached to a stream, and the NAT server keeps a cursor of like what's the last message that was acknowledged. And there's a couple policy around it as well. But as you set up your consumers, you could actually tell there's a lot of different options for how you can set up your consumer in terms of like what you want it to receive. Do you want to start at 0? Maybe you're event sourcing something, you're spinning up a new server, and you do want to process all of that stuff. Or maybe you just want to start at like, give me the very last message that came in, or don't give me any messages that are not that are older than when I started this connection. And so there's a lot of different ways you can configure a consumer, and and that's also really helpful. You can also say this consumer wants to consume from the stream, but filtered on this particular subject, which is also really interesting too, because you could have a big stream that's kind of like your global, let's say append-only log, but you only have a consumer that cares about this subject off of this stream. It doesn't have to consume all of the messages, just consumes the ones it cares about. So you have options.
And is it possible for us to configure the Jetstream to say, okay, keep this information for X amount of days?
Yeah. Yeah. So the retention policy around limits, you can say, I want to limit it at this amount of messages or this amount of days, or here, I was looking at the retention policies here. Let's just say a NATS stream had, let's use a NATS CLI to create a stream with subjects. Storage, do you want it in memory or a file storage? Replication. So again, if we're operating in a cluster, I can make this an R3 so I can have like durability. So if like one of my hard disk gets hosed or something like that, not totally screwed if you need that amount of replication. I talked about retention policy, which is like limits, interest, or work queue. Interest works a lot like a Kafka, where it's like you could have one big stream and it's going to throw messages away if nobody's interested in them. But as soon as you create a consumer that's like, I'm interested in this stuff, it will like persist those messages. Work queue is like what you would think of for any sort of durable queue. Like as soon as it knows somebody has gotten that message and processed it, acknowledged it, it's going to throw away that message. So like we're talking about limits. So you can say like, as soon as it reaches the limit, do you want to discard the old one, or do you want it to like throw an error for all new incoming ones, like if your disk is full or whatever? You could say how many messages do I want as a limit? How many per subject messages do I want as a limit? Like if you're trying to kind of control some multi-tenancy inside of a single stream. What do you want the total stream size to be in terms of bytes? How long do you want a particular message to last? Give it a message TTL or a max size for a message. We have duplicate time track. Like there's a lot of options here. There's this idea of rollups, which is really cool for being able to snapshot some messages if you want to tidy things up, depending on what you're doing with your stream. If you want this to be GDPR compliant, want to be able to delete a particular message from the stream, you can purge based on a subject, or you can purge the entire stream. There's a lot of different options for how to set that stuff up.
Hey, really cool. Thank you.
Yeah. Just because I mentioned it, I know we have 5 minutes. I'll just show you guys really quickly, and maybe you guys can play with it while I talk. What is it? Where is it? Right here. I just deployed this to render. This is all a, let me just go to here. Get a new whiteboard for y'all. It's built using 100 lines of JavaScript and connecting directly to NATS via WebSockets. It's using Jetstream to persist those messages. So when you refresh, it's kind of doing that ephemeral consumer thing where it's just starting at 0 and catching up. So you'll kind of see, if it's a slow connection, you'll see the drawings kind of show up as it's pulling in the data. But let me send this in here, and you guys can feel free to just like play with this. Where's chat? There we go. Cool. Awesome. So yeah, you guys can go ahead, start drawing, pick a color. All of these things are coming in as little NATS messages that are basically just like mirroring the Canvas API for drawing. And the cool part is if somebody clicks the little trash can button, that actually does a roll up that says clear all these messages, and it actually purges those messages from the stream. The other interesting thing is this stream is set up to be I didn't want like this thing to get out of control if I like shared it on Hacker News or whatever. So these things have an expiration of like 30 days and they go away. So they're just kind of these like little ephemeral whiteboards, but it's super fun because we're just using NATS to do this, no backend or anything, which I think is pretty fun. So cool. Okay. I want to talk about server topologies. And I know we're like almost out of time, so I'll just zoom through this. It's actually one of my favorite things is scaling NATS. So let's just quickly jump through this. Okay, so you could deploy on a single node, and like single nodes are pretty high performance, which is great. They use resources really efficiently. But if you wanted to start clustering these things for both resiliency and for performance, NATS servers are actually really easy to cluster. We use a gossip protocol for these servers, and we also use a gossip protocol to the clients about the servers. So if one server goes down, the clients aren't hosed. They actually just move on to another server in the cluster, which is great. NATS is really good at self-healing, especially in terms of the the connection to the servers and the clients. You can do a 5-node cluster. This kind of shows that like this is all meshed. So we use a mesh networking topology for our clusters. And usually a cluster is going to get you like pretty far. But when you're talking like multi-cloud, multi-geo, some of the things that we had to solve for is like, all right, what if you have this cluster in AWS, you have this over in Azure, like, over in Europe somewhere? Like, how do we have these things talk to each other? And you actually can, like, because NATS is really simple in how it connects to each other and how they connect to each other. You can actually like bypass a lot of like the networking BS that a lot of these cloud providers like give you, and just have NATS do its thing. And so you can connect these superclusters via gateway connections to each other, and NATS will just pretend it's all one system, which is cool. I don't have time to talk about this. I really wish I did. But we have this concept of leaf nodes, which I'll say is like your own little private island where you can extend a supercluster, but you can operate this thing as its own NATS deployment. And you basically get to specify based off of our security model, like what subjects you're interested in or what streams you're interested in, and replicate those. And this is really powerful for the edge. Like imagine you're an oil rig and you're collecting sensor data on, a particular on all the particular sensors for that oil rig, but you have a spotty LTE connection. Well, you can actually leaf node, a Jetstream stream where you're sending all these messages locally here, and you can tell the supercluster to be like, yeah, replicate that stream for me in the cloud. And NATS will be smart enough to, as soon as we get enough connection from LTE, we'll start sending that data up to replicate. So it's like super powerful. And one of the reasons we're starting to see these massive topologies like show up everywhere. It truly is multi-cloud, multi-geo, super composable. Clients don't really need to care where they're connecting to. Like I'm not saying go connect to the NATS cluster over in the EU. We're just saying like, here's your one URL, and NATS will like tell the client which NAT server is like geographically closest to them, and then it could just start working, which is mind-blowing. I wish I had more time to dive into this, but the short answer is like NATS is super easy to scale, and you have a lot of flexibility to where you can solve for some like massive, some of the companies we're talking to are the ones who are actually bumping up against some of the biggest scaling challenges in the cloud these days and at the edge. And really they're using NATS to solve some of those problems because there's literally nothing else that can. So high performance single nodes, moving from a node to a cluster to a supercluster to an extended supercluster with leaf nodes being these little private islands. I could run a little leaf node of a Raspberry Pi connecting to a larger system, which is really cool. And then again, like I mentioned before, this intelligent routing to the closest responder makes for a really cool story when you have this like global deployment. So NATS for microservices, what's the kind of the gist? Well, you can simply use request reply like you always have. Like I would start by figuring out, I wonder if we can get a lot by replacing some of our HTTP stack with like NATS, with how all these services talk to each other. And then you could leverage NATS features when needed. And here's what you get for free. I think it's actually going to save a lot in some of the complexity if you start adopting NATS instead of HTTP for how these things talk, because you get free load balancing, you get free pub, sub, and streaming with certain constructs. So you can be like, we don't have to adopt this new technology. If we're already using NATS, it's much easier to be like, well, this can just be a stream. You get free key value and object stores. You get free observability with that like wiretap mode that I showed. You can actually like build monitors for all this traffic, for your requests and your responses and your publish and subscribe. Like you could have something that just literally monitors everything and goes and sends that off to a log aggregator or something. You have decentralized auth-in and auth-z for your services, which I wasn't able to show because it's a big topic, but the security model around this stuff is like excellent. The way it's decentralized and uses zero trust constructs are so cool. You get free service discovery, free geo-aware persistence. So if you can't store data in some region because of policy, You have a lot of control over that with Jetstream. You have free failover and disaster recovery. Let's say your NATS cluster goes down, in the US for whatever reason. You don't have to have like all of this tech built around disaster recovery because of how NATS smartly routes stuff. It basically gets routed to the other closest region or cluster, which is really cool. And then you get, again, all of this is wrapped up in this idea of location independence, which is like clients don't care about who they're talking to. They just know they're talking to the NAT server. And it makes for a really good scalability story, because if you want to get something more at the edge or closer to the person who's asking for it, you simply just deploy more compute in that area. And all this happens in a single deployment of a NAT server. Like the multi-tenancy story is just so excellent. I wish I could talk more about it, but I'm sure all this sounds really too good to be true. But like one of the reasons we're just starting to talk about this now to like more companies, because we've just been working so hard in the background solving some of these really big problems. And there's a lot of momentum around some of these big innovative companies starting to solve big problems of scale. And so that's my talk. If you guys want more information, feel free to hit me up. I'm Jeremy at Synadia.com. If you guys are interested in a hosted solution, we have that NGS, which is our big global supercluster for NATS. And that's my talk. Any questions?
Yeah, I had one question. How does the scaling work in correlation to like a ton of subjects getting made? Like, what if you had a subject per client and you were just like sending a message to a wildcard that's like, send this to every client essentially?
Yeah. So NATS creates what we call an interest graph, which they replicate across all their other servers. One of the things that we're working on that generally works pretty well, like usually you could just throw more memory at something to get the interest graph, and it might be a little bit more costly, but it's really not all that bad. Like we still see connections and subjects in the tens of millions, but like we're interested in getting into the billions. And the way that we're going to start doing that, we're working on a new feature that kind of partitions that interest graph based on leaf nodes. And so you can start thinking about your global topologies being more like, well, these people are mostly here out of the here in the EU, so we can have an interest graph that's like more coupled toward them, and it's still adaptive, but it just does a lot better management of the interest graph memory. So you don't have to say we're going to throw, if we have a billion subjects, we're going to throw a terabyte of memory onto every one of these servers that are managing the clusters. Yeah, it's a hard problem, right? Because we're not DNS, we're not distributed like that. Right now we have the interest graph just like as a big blob of data. But it actually scales quite well right now. I just don't think we don't think it's gonna scale for like tomorrow's problems. And so we're really interested in currently working on like that scaling story. Is there a single type of underlying data storage? Does each server need to have enough space to store all the sum of the nodes? In terms of hard disk for like Jetstream, like you would want to configure that. Consider that as you're deploying. In terms of memory footprint, like if you're using core NATS, you don't really have any disk you need to write to. But there are memory requirements. We're pretty efficient with our memory, and we're also on a per subject basis, like reducing that. I think I have a slide somewhere that says like on a per subject, like how much memory it's taking up. But for the most part, for most folks' applications, like we know we're in a good place when people are making trade-offs between hardware and network, compute, disk, instead of fighting with the software. And so we're continuing to optimize for that, but it does things in a pretty efficient manner. Thanks, everybody. Really appreciate the time. And feel free to hit me up, send me an email. You have it on this invite. And hopefully we'll talk soon.